like I said, if you want to write this down somewhere, that's up to you. This is just reviewing some ideas that we will talk about as we go through examples. And we talked about these ideas starting on Thursday, again on Friday, and now because we're picking up in the middle from what we did Friday, I just want to review these again. So say you are given the graph of a function f. How will you know where the derivative f prime is equal to 0, or if the derivative f prime is equal to 0? So what has to be true on the graph of f in order for the derivative to equal 0? A horizontal tangent. So f prime will be 0, and this is if f has a horizontal tangent. And typically those will occur at a local max or a local min. There are other places f could have a horizontal tangent, but that's typically where they occur. So anywhere you see a horizontal tangent, you know the derivative will be 0 or will cross the x-axis. How do you know if the derivative will be positive or greater than 0? If f is increasing. And then likewise, f prime will be less than 0 or negative if f is decreasing. So I know we started out on Friday, and I know some of you weren't here, but we started out on Friday where we actually picked specific x values, drew the tangent line to the curve at those values, approximated what the slope of that tangent line was to get the value of f prime at those x values. However, that is not the process we will be using to graph derivatives all of the time. That was just to get you the idea and the understanding that the graph of f prime represents the slope of the tangent lines to f at any point x. And then it really allowed us to see these three ideas. So the last two examples we did in class, these are the things I typically look for at the start, and then I also look to see as I'm drawing in f prime, I look at the steepness of the slopes. So I want to recap what I talked about with these two on that page before we go through the third one on that page and then the very last one on the back. When we looked at this top one, we said at no point does f have a horizontal tangent. So f prime of x is never 0, and then f is increasing on its entire domain, so f prime was always positive, so our graph was completely above the x-axis. And then I said, even though I'm not drawing in slopes of tangent lines, if I did, my tangent lines are going to start out with very steep slopes, and then they are going to get flatter and flatter, or the slopes will approach 0, meaning on the graph of f prime, my y value should start high and approach 0. And that's how we got our graph of f prime. And then for the second one, again, we saw f prime of x was never 0 because there were no horizontal tangents. In this case, if we have a vertical asymptote for f, that's also a vertical asymptote for f prime. But on both pieces of this curve, f was decreasing, so f prime should be completely below the x-axis, always negative. And for this first part, these tangent lines would have slopes that are starting out close to 0. They're flatter and getting steeper, so the y values start close to 0 and get more and more negative. Versus on this part, the tangent lines start out very steep and get flatter, so the slopes approach 0, so the y values start out very low, negative, and get close to 0. So those are kind of the things you want to think about as you're graphing. If we look at 6 and talk about this same idea, in this case, is f prime, or rather, are there any horizontal tangents for f? At 0? I didn't know if you were saying 0, if you were saying at 0 there's a horizontal tangent, or are you saying there are 0 horizontal tangents? I wasn't sure what 0 meant. Right here. This is like your x-axis, and this is your y-axis. This would be the origin right here. Yeah. Right, this is approaching 0. So I said, are there any horizontal tangents? So there wouldn't be. Here. Yeah, I would say like this tangent line would probably be close to 1, the slope. Is that what you're saying? Okay. All right, so on this graph, these y values do approach 0. So closer this way, your tangent lines probably have a slope that's very close to 0. But again, f prime of x, like the other two on this page, is never 0. So f prime should not cross the x-axis anywhere. And then f, in this case, on its entire domain, this curve we are given is always increasing. So then we know f prime will always be positive. So it will be completely above the x-axis. And so now, if I think about the slopes of this curve, if I were to draw in tangent lines, the slopes are going to start out nearly horizontal, not quite, but the slopes will start close to 0. And as I keep drawing tangent lines, they will become steeper and steeper. So that means f prime is going to start close to 0 and then increase more and more and more. So the graph of this derivative will very nearly be, it'll be the same shape. It could potentially be the exact same curve, but we don't know that from what we're given, but it would be the same shape. So this is important for you to see that if you have a function that is exponential, this would be an exponential curve. The derivative of an exponential curve is also exponential. So that's important to note. Could be the exact same curve, not necessarily, but an exponential curve does have an exponential derivative. We are just looking for the shape. So do I know the exact y values? No. Am I looking for you to know the exact y values? No. I just want to see that you have it placed correctly and the shape is correct.
Could it be above the graph?
Yes. Yeah, if you drew it above, that's fine. Yeah. Yeah, so when you get to practicing these on your own, and I'll remind you of this, here's how I'm looking for you to sketch these, or rather how I'm looking at your graph when I'm grading it. I'm looking to see that if f prime is ever 0, that you have the zeros plotted correctly. So your f prime is crossing the x-axis in the right places. Your graph is above the x-axis in the right places and below the x-axis in the right places. But in terms of the exact placement of the graph of f prime, I'm not looking at that. I'm looking at the shape, and that you have, like I said, the zeros and above and below the x-axis correct. I'm not looking to see, well, on the graph of f prime at the x value 2, f prime should be 5. I'm not looking that specifically. We're getting the shape down, not necessarily the exact values at this point. The last graph, I do have two of the same graph on this page on purpose. Because on the top one, I want to, well, rather on the bottom one is where I'm actually going to draw f prime. The top one I'm going to label what's happening on the graph of f as to why the graph of f prime looks the way it does. So that's why I included two of the same graph. So We're going to look at this graph in pieces. We're first going to look at this piece here, this horizontal piece. So first of all, if this piece is horizontal, yes, that means for this entire piece, from the x values -4 to -3, f prime of x will equal 0 because that piece of the function f is horizontal. Now, at this corner, can you draw a tangent line to a corner? No. So because this is a corner on a graph, there is no tangent line here. You can't draw a tangent line to a corner, meaning f prime of x doesn't exist at the x value, in this case, -3. So this would be represented on the graph of f prime. This would be a hole on the graph of f prime. Okay, so I'm going to draw that piece in. So from -4 to -3, the graph, I'm going to use a highlighter so you can see it a little bit better. But the graph of f prime would be 0, so on the x-axis, except at the x value -3, there would be a hole. All right, questions on that? Okay, for this next piece on the graph of f, we can see at the x value -1, there's another corner, meaning that's going to be another hole in the graph of f prime. But from -3 to -1, that piece of f is linear, meaning if it's linear, the tangent line is just equal to that piece of the curve, so f prime is the slope of that piece. Linear functions have a constant slope, so f prime is still constant there. What is the slope of this piece? 3/2. So f prime of x from the x values -3 to -1 will equal -3/2, or +3/2, sorry, or just 1.5, 1.5. So this is an instance, because we can actually calculate what that slope is, on my graph of f prime, I should have this piece on f prime at 1.5. And it is constant, so from -3 to -1, f prime doesn't change. It stays at 1.5. So for f prime, I'm going to jump up to the y value 1.5. I still have a hole to start, and then it's constant at 1.5 until I get to the x value -1. And then, yes, another hole because there was another corner. So realize the derivative, this is important to note, the derivative of a linear function is constant because linear functions have a constant slope, and the derivative is the slope. And then we have another horizontal piece from -1 to 0. So again, here f prime of x will be 0. And there is another corner there at 0. There's another hole. Another one.
Another one. What did you get, Howard?
Okay.
Just say it. Come on. Please. Another one. Another one.
Okay. And then this piece of the graph. Now this piece is no longer constant or linear. So we're working through this like we did the previous graphs. On here, there are no horizontal tangents. This piece is completely decreasing from 0 on. So that means f prime of x here should be negative or less than 0 below the x-axis, not crossing the x-axis. And then the tangent lines for this piece would start out steep and get flatter. So f prime would start with, however you want to say it, either, I don't know, high negative values, which are actually really low values, however you want to describe it. So f prime of x would start with large negative values, which are actually really small, and approach 0 but never equal 0. So it would look, what do you mean? Kind of. Yeah, so this is what it would look like. I'll draw it. I realized I should draw it on the other piece of my graph to complete it. Oh, you mean like start it here? Yeah. You could. The idea though is like at 0, there isn't a tangent line, but that's very, very steep. That's just the idea you're going with. It's probably steeper than -2. All right, so this, what's highlighted in blue would be the graph of f prime for that function. So it's really understanding if I see a graph of f, what would the graph of f prime look like?